Balázs, Zoltán.
Hello and greetings, everyone. I'm really happy to being here and presenting here because the last 1.5 years was also pretty bad for presenters. You cannot imagine how hard and frustrating it is to be engaged when you can only see from the audience that your webcam light is green, and that's all the feedback you get from the audience. So I'm pretty happy being here. And this is going to be a joint presentation together with Patrick Ross. He's in Canada right now, so unfortunately he cannot join us. But what you have to know about Patrick is that he's the co-founder of Village Idiot Labs. And Village Idiot Labs is interested in IoT security research. He's also a content developer. He has created a lot of labs and CTF for IoT Village, which he's a co-organizer of. And he's also a DEFCON 26 black badge holder. He used to say, deal with it, or something like that in this slide. My name is Zoltán Balázs, and I'm the head of one research lab at Kujo AI. I'm really into offensive security research, and one of my press presentations was about the zombie browser toolkit. I created the hardware firewall bypass tool, malware analyzer sandbox tester tool. I also played with some crappy IoT devices, and I published one of my exploit codes online. And it turned out that some guy was copying my code into his botnet. So my code was running on 600,000 IP cameras, at least. So this is one of the codes I wrote, which were running on more than one computers. So I'm pretty happy about it. I also invented the idea of encrypted exploit delivery. I'm the co-organizer of the Hacker Shuli meetup, and I'm program committee member at Hacktivity. And actually, this is my 12th presentation here, if I count it correctly, or maybe even more, I'm not sure. And I volunteer at IoT Village. So why are we here? If you are into emulating IoT devices, or you are interested in the suffering of embedded device development, then this is your place. Or if you have ever debugged any MIPS assembly or binary, or you want to build a lab for your IoT devices. If one of the answers is yes for this, then just enjoy the show. Otherwise, I hope I can keep your attention with some memes or jokes or whatever. But please stay for the learning opportunity. So why did we start this research project? IoT Village is visiting a lot of conferences every year, and they are hosting labs and CTF competitions there. And it quickly turned out that bringing 40 different IoT devices to all of the conferences has its own challenges. They are heavy. You need a lot of cables to configure this. Networking can be flaky. So it's a lot of mess. Just imagine when you have such kind of infrastructure and you have to move it from conference to conference. A lot of cables, a lot of issues. Usually something will fail, right? This is not optimal. And if you are into exploit development, this is the traditional way of debugging IoT devices. If you are lucky, you can find a debug port on your IoT device. You use your favorite debugger, and you just try to hack it, right? This is not a beginner-friendly solution in itself, especially if you don't know what you are doing. You don't know how to wire things up. It's pretty hard to debug why the debugging is not working, right? Also, if you want to do, from a software point of view, vulnerability research on the device, first you need root privileges, then you can do some debugging on it. But this can be a catch-22 situation that you want to do vulnerability research because you want to find new vulnerabilities, But if there is no known vulnerabilities, how do you get root so you can debug? So it can be pretty complicated very quickly. Also, if your favorite debugger is GDB server, for example, and you try to run it on a regular IoT device, you cannot run it because this binary is not on the device. All right, what do? You try to download it, but you cannot download it because the whole file system is read-only. So you can imagine that this is going to be a pain very easily. So we started to look around. Probably we are not the first ones trying to solve this issue. So we checked what kind of tools are out there. There's Thermodyne, and it's great, but it was a bit bloated for our research purposes. You can also find a lot of outdated, incorrect blog posts about how do you do this manually. It can be a lot of fun or a lot of pain. Depends on your definition of fun. There's also a very nice project called ARMX. This has been created by Xiaomil Shah, and this looked a very promising project. Our only issue was that there was no MIPS support in it. As the name suggests, it's only written for ARM devices, but we want it to emulate MIPS as well. So I figured, let's use ARMX and add some MIPS support to it. So in the following slides, I will talk about CPU architectures, virtualization versus emulation, some screenshots from the pain we were having during this research. I will talk about a little bit of kernels, file systems, NVRAM, QEMU, Docker, and the demo. So CPU architectures. Most of you know Intel or AMD, which has a complex instruction set. You can find it on all kinds of desktops and servers. You probably heard about ARM as well. Most of the phones are running ARM, also a lot of IoT devices. It's a reduced instruction set CPU, and now it's also available in MacBooks, for example. There is MIPS, which was the target for research, which is again a reduced one. And there's PowerPC, which is also reduced one. It used to be on old Apple hardware, but you can still find some IoT devices with this special CPU. And there's Spark, which is sometimes on high-end servers, for example. You probably have seen Intel or AMD assembly. This is how it looks like in GDB. Here you can see that there are some registers that you have here, and here are the very common assembly instructions. You might know that mov, call, pop, ret, nope, whatever, right? I'm not sure how many of you have debugged ARM, but it's a bit different because it is reduced instruction set. You will see a lot more registers. These are here. And the assembly instructions are sometimes similar, sometimes different compared to what you are used to in Intel or AMD syntax. And this is a MIPS 32-bit binary, again reduced, so you can see a lot of registers. And here, you might try to figure out what are the meanings of these instructions, like move and add and stuff like that, but it's becoming more and more exotic compared to what you are used to, right? And finally, I have created a screenshot for PowerPC as well, because I can. Again, reduce one, lot of registers, and here are the instructions, which I not try to find out what these are. I have no idea, but it's just pretty strange for me. Anyone debugged PowerPC CPU here recently? No one? Okay. So let's just talk about virtualization versus emulation. I guess all of you know the traditional virtualization like VirtualBox, VMware, Parallels, whatever. You use virtualization that you only have one hardware, one CPU, but you want to run multiple different operating systems inside it in parallel. And if you are on the Intel or AMD architecture, then it is just great. You can run any type of Intel or AMD OS inside those. The issue is, if you try to do this cross-CPU architectures, then it's not just about emulating or the hardware itself, but you have to also translate and emulate the CPU instruction sets between the different CPUs. And guess what? It will be slow, but luckily we have the QEMU project for many, many years around, and it is the #1 best tool if you want to try and run operating systems or binaries from a different CPU architecture. Just a show of hands, how many of you guys have played with QEMU in their life? Okay, that's good. That's good. So basically, you might have heard about the QEMU development boards, which are almost like something like virtual machines, where the hardware and the BIOS is emulated. What's challenging in the IoT exploit research area, that if you try to copy an IoT device and you get the whole firmware from it, if you try to run the same kernel inside QEMU, it will not work. The reason is that all IoT devices, they have a very, very limited storage space. So clearly they will not compile their kernel with support for all kinds of different hardware, right? They will only compile the code for that specific board which is in the IoT device. And you might try to customize QEMU itself and try to mimic the behavior of the original IoT device, but probably this will be a very, very long journey. So, but if you need a new kernel and you have to build your own kernel, what do? The usual recommendation from the internet is just use Buildroot, which is fine most of the time, except when it's not. But for example, if you need an older pre-built kernel, then I highly recommend you to check out this very old website where some very, how can I say, so a guy basically provided different host file systems and kernels for very, very old systems and provides it just for free for everyone. I already mirrored this website because if this goes down, I will be in trouble. So anyway, here you can find some very, very good archive of old kernels and file systems. What's really great about this repository, that after some hacking around inside the system, you can make apt-get install work, which is really, really great, because with the Buildroot way, when you create your host file system and you forget to add any component to this, you only have two ways to add new files to the system. One is that you recompile your host file system, which is going to be a pain, or you compile your binaries usually in a statically way and add it to the system. Apt-get install is much, much easier. But if you want to compile an old kernel like 2.6 or 3 point something, and you want MIPS kernel from that, there will be a warning here. It's not going to be an easy journey. You cannot just download the latest Buildroot and compile a very, very old, like 10 years old or 15 years old kernel with it, because it will be incompatible. Also, if you look at the sizes of these host file systems, the pre-built Debian ones are pretty large compared to the Buildroot ones. This might be an issue for you or not, depends on your workflow. And if you want to hack your Debian system to make it compatible with apt-get, I just recommend you that you start a network proxy on your host device, you set up a socket for a DNS server, you change the resolve conf file in your host file system, you configure your opt configuration to use this proxy server, and also you should replace the repositories in opt from FTP and security to Archive. And I'm not sure how many of you guys are familiar with this Archive Debian repository, but like 6 months ago, I downloaded an Ubuntu 8, which is like 13 years old, and I replaced the repository to the Archive one, and I was able to update it and install all the tools I wanted. So this is really, really great. And I'm not sure how many other distributions have this capability. So I already mentioned the word pain, and this is going to be the slide where I show you what I meant here. So talking about this very old Debian Ubuntu version, if I want to compile with Buildroot, then there will be some issues. Like Buildroot wants to download stuff from the internet. Guess what? SSL will break, clearly. Or because some of these archives are very old, download speeds will be also pretty slow. Or when it comes to compiling the kernel or the host file system, you will see some errors. For example, a fatal error. I really like this term, fatal error, like someone played a lot of Mortal Kombat, or I don't know. If you try to debug stuff, you will see very interesting and error messages which you cannot decipher. You will see some errors and other errors, and some tools will be missing, and you will see missing tools and errors. And this is how this was going on for 4 weeks, that I was trying to bashing errors after errors, and nothing worked. It was pretty interesting, but not fun at all. And there were some errors, and there were some errors, and guess what? Here's an error. Here's an internal compiler error, segmentation fault. I had no time to check this, but this looks promising. Here's the very old Ubuntu, which I have used. It started with a kernel panic, of course. Yeah, here's an error, and there's an error. Guess what? Here's an error. Error. And this one is the best. Cannot find Ninja. Like, I was trying, this was like latest MIPS, and everything was pre-configured, and I just had to run a bash file, and this was the default message I got. Cannot find Ninja. Okay, whatever. So it's going to be challenging, I can promise, if you try to compile an old kernel or old host file system. Yes, talking about cross-compiling. Cross-compiling is the word if you have, for example, an Intel or AMD notebook, and you want to compile a binary for a different CPU architecture set, like ARM or MIPS or whatever. Most of you are familiar with compiling. There can be errors with compiling. If you do cross-compiling, there will be a lot more errors, and it will be even harder to figure out what's going on. But unfortunately, most of the time, cross-compiling is the only way which you can try. If you already have a working OS inside QEMU for that specific CPU architecture where you want to compile something, you can try and run the compilation inside that, but because QEMU is very, very, very slow, it can take days or even weeks to compile just one binary. And if there will be an error, then just retry it. So cross-compiling is unfortunately the only way we have now. I guess not many of you have very powerful development boards for MIPS or ARM or things like that, so you can build stuff at home. Actually, for ARM, you have Raspberry Pis, so that's great, but for MIPS or other architectures, it's really hard to find a computer where if you don't want to do cross-compiling. So, as mentioned, the IoT space is full of old hardware and old kernel. Still, a lot of devices run 2.6.32 kernel. If you are into Linux, you know that this is old, like very, very, very old. Right now, building a recent MIPS kernel is pretty easy. Just follow this guideline, and you can quickly have your MIPS up and running. Also, as I mentioned, sometimes it makes sense to build your tool set in a statically linked way, so you can just drop it anywhere where you want. If you are using Buildroot and forgot to add something into it, or there is not even an option in Buildroot to add stuff, like I have compiled GDB server, netcast, socket, telnetd, this kind of stuff. You will need this in exploit development. I mentioned cross-compiling. Luckily, you have a lot of options to choose from, and most of them will not work, as it turned out. Buildroot is one of the best way to create cross-compilers and tool chains. We have OpenWRT, which is basically a fork of Buildroot. CrossToolNG, Muscle, Code Sorcery, CodeBank worked for us best. And if you want to compile the static binaries, use the Muscle tool. That's what worked for us. Yes, that's some wisdom here. But after a lot of trial and error, you will be greeted with something like this, where you have a working, where you have a working login shell, and you are pretty happy about this. These were the operating systems by the time when I was able to do that. That's quite a collection, I would say. Our project is aiming to do full system emulation, but don't forget that there's also always an easier way to run binaries. If you just want to run a single binary from a different CPU architecture, QEMU can easily do that for you, and you don't have to deal with these complicated frameworks. So just use these commands if you are interested in running MIPS binaries on your Intel CPU. You write your hello world program in C. You can easily cross-compile it with this command. If you don't want the statically one, but you want dynamically linked one, use this one. This was basically copied from Azaria website. She's into ARM reversing, but just replace all the ARM words with MIPS, and you get the same working and up and running. And this is how it looks like in practice. Here's the hello world. I'm compiling it in a statically and dynamically way. As you can see from the output of the file commands, these are MIPS binaries, and the host operating system is just a regular 64-bit AMD one. And if I just run hello, QEMU automatically does all the magic, and you can run a single binary from the operating system. Funnily enough, if you try this with the dynamically linked one, it will not work out of the box. But luckily, we are used to this, and there's a very easy and quick fix to do that. So, talking about the MIPS architecture, luckily there are many, many different MIPS CPUs out there, and whenever you do emulation, you have to check which one you are trying to emulate here. One of the key, how can I say, best practices to do IoT emulation is that you build your host file system, which will be simple BusyBox, for example, when it comes to Buildroot, or the already mentioned Debian images. And you boot that one. You somehow mount or copy all the files from the firmware, from the device you want to emulate. And you just chroot into this target directory, and then you kick off the OS initialization from there. And this gives you the flexibility and debuggability of the device, because you have all your tools on the host file systems, like you have the SSH or the GDB server or whatever you need, but still the underlying files and applications will start from this chrooted directory. As it is the case with all kinds of virtualization and emulation, you can use both persistent or non-persistent disks, depends on what you like. If you go to our GitHub webpage, I have collected some useful information if you want to build your own host file system, and what are the configuration options you have to do if you are interested in that. Now, let's discuss a little bit about NVRAM. I really like this word NVRAM, I have to admit, because what it stands for non-volatile RAM, right? In school, we were told that we have the read-only memory, and we have the RAM. And read-only memory, you cannot write into this, right? From a user's perspective, and RAM is something where you can read or write all the time, but by the time you turn it off, it will lose its state. And for me, non-volatile RAM is just like writable ROM. Like it's like the similar word to me. But anyway, what is NVRAM? I guess everyone has a Wi-Fi router at home. Whenever you do any configuration change on the web UI, all the changes go to this non-volatile RAM. Because to make IoT devices cheap, they are using special storage for all the firmware files, which are mounted in a read-only file system. And it's only writable, for example, during a patching process or something like that. But you cannot store these configuration options in a read-only file system, right? So that's why IoT devices have this special place called NVRAM, which is writable all the time, but whenever you reboot your device, it will not forget stuff. In order to emulate IoT devices, you also have to emulate NVRAM, and you have to figure out from the original firmware what are the NVRAM parameters needed for all the applications running on the IoT device. So we are still talking about QEMU. Networking can be challenging with QEMU. By default, you can run QEMU without root privileges, but the default network interface will not be a fully functional one. For example, ping will not work, which kind of makes troubleshooting funny when you forget that ping will not work. Most of the time, it's better just to run QEMU as root and use the tap interfaces. When it comes to exploit research development, you always want to emulate the device with the same settings as it was with the original IoT device. Meaning that if you create an exploit which deals with memory addresses, for example, then you want to have the same memory layout in your original IoT device. So you have to take special care and check for these. I don't want to talk too much about this because time is running low. But let's talk about Docker. Initially, the RMAX project, which we forked, was using either some VM images or pre-built images, but no Docker. And quickly turned out that it is very hard to play with this stuff and maintain stuff. So we started to port our solution to Docker. And once we finished it, turned out that Xiaomi is also working on porting his project to Docker. So right now, finally, we have RMAX under Docker, and this is really, really great. The way it works is that you have your host machine, and inside the host machine, you have your Docker container. And inside the Docker container, you start the QEMU emulation. And the QEMU emulation will kick off the host file system and host kernel. And then that can boot up the Sage-rooted IoT firmware root file system. And this OS is basically responsible for booting all the application processes. I'm not sure how many of you guys have seen Inception. Yes, this is Inception. Like, you are very, very deep in your dream, and honestly, sometimes I have no idea what I'm doing, like which console I'm in, which layer I'm in, where is the error, how do I debug. It can be a real pain. But after a while, you can get used to that. And as mentioned, what's really great in this host file system plus Sage-rooted environment, and that you can put all your tools inside this environment, which was probably missing from the IoT device. Like, not all IoT devices comes with SSH daemons and GDB servers. All right, now let's talk about the demo gods. I hope the demos will work today. Yes, VLC works. So let's start the Docker container. And as you can see, this is the modified MIPS-X version with the MIPS support. Let's start the Docker shell. And with the launcher command, I'm going to start this IP camera, which is a MIPS-based camera. After some seconds, it boots. And once it's done, we can log in into this host file system and kick off the init process of the IoT device. Here you will be able to see a hell of a lot of errors, and it's always fun to figure out which one of the errors are interesting for you, which one of the errors you have to fix, and which are not interesting. You will see these errors most of the time because you are not emulating the full hardware around the IoT firmware. For example, in the case of an IP camera, I will not add camera like device to QEMU, so it can pass it to this firmware. But there are so many things which can go wrong, and it will take a lot of time to figure out what do you need so that all the applications are running which are interesting for your research purposes. So as you can see here, we are running a MIPS-based operating system emulated under QEMU. And let's check what kind of services we have. As this is a cheap Chinese camera, we have open telnet process. Guess what? With the username admin and password 12345, you can log in. So there's not much research into this camera. But otherwise, you can see some interesting daemons running here, which you can start to fuzz. And what's really great, that now you have access to GDB and GDB server. So you just use the process ID of the process you want to debug, and you have access to everything. The registers, the decompiled code, you have everything here. So whenever you want to do vulnerability research, this is the real stuff, what you need. Our project is still not yet finished. We have some stuff to do. The NVRAM emulation is not yet finished properly. And if we will find the time, we also plan to do a CI/CD pipeline, which can automatically unpack firmwares and put it in an emulated IoT environment, so you can easily do whatever you want. So we are releasing our code because we believe in open source, and we really hope that if more and more people can access these devices, fuzz these devices, and debug these IoT devices, then more and more vulnerabilities are found, and hopefully in like not more than 20 or 100 years, IoT security will be improved. You can find our original code on the first link, but we also created a GitHub pull request to the original RMX repository. It's not yet merged to the project, but if you are interested, I recommend the second link more, because that's where you see all the fancy Docker stuff. So that's all I wanted to share with you. I hope you enjoyed the presentation, and if you have any questions, feel free to ask. Thank you.